on this conversation as we talk about the state of RAG, the next pioneering the next wave of AI in search. How are you today?
I'm great. I'm always passionate to talk about neural search and RAG, and I'm really looking forward to this conversation with you.
Yeah, I am as well. I've been following Zeta Alpha for quite some time. Zeta Alpha was one of the first sites that I came across. Some of the content you were putting up on YouTube was phenomenal, and I started really enjoying the conversation that you were creating way back in the day. So I'm really pleased to have you here and have a conversation with Rag and see where we've gotten to over the last couple of years. Let's do some quick introductions and then we'll get into our conversation. That sound all right?
And by the way, we're also streaming this on our Neural Search Talk channel, as a parallel or co-production.
Fantastic. Perfect. Yeah, hopefully we'll get lots of good people in. And if you're on, please feel free to ask questions. Join us in the chat, and we'll have we'll answer the questions live as they come up. So first and foremost, hi everyone. I'm Eric Schwartz. I've been innovating in search and knowledge discovery for over 20 years, revolutionizing how users find and engage with their most vital content. My recent work was with Scopus AI, which was a groundbreaking AI and large language model, LLM, discovery experience over this large corpus of academic literature. Scopus has over 90 million peer-reviewed academic articles in there, books, and that are peer-reviewed and selected for academics and researchers. And the Scopus AI created a new interface using RAG to really find a new way to engage with that content. Before I was at Elsevier, I had been working in the cable TV domain, where I was responsible for a team that built a knowledge platform that powered a video experience for Comcast. I've been working in the search engine space and the search domain for the better part of my career. Today, Jakub is here, the CEO of Zeta Alpha, and we're going to discuss the state of RAG. Which, if you don't know, stands for Retrieval Augmented Generation, as the next wave of AI-based search and neural search. Jakub, over to you for a quick introduction.
Thanks, Eric, for having me on this conversation. I'm Jakub Zavrel. I've also been around for a while in the search, NLP, machine learning, and AI space. First as a researcher in machine learning-based NLP in the late 1990s. Then I started a company called TextKernel, which applied, at that time, statistical NLP and search in recruitment. First pioneering sort of the use of AI in HR and recruitment. And in recent years, I've been busy with innovating in AI-centric knowledge discovery with Zeta Alpha. And basically the idea is that now that we're getting machines, that is LLMs, that can understand content at a human level of intelligence at scale, that this completely changes the equation as to how knowledge is used and reused in tech and really in any sort of knowledge and R&D intensive industry. And I think that organizations that are getting this new revolution, have a huge competitive advantage in making the right decisions, getting ROI on their expertise and R&D investments. And so with Zeta Alpha, we kind of started pioneering, applying neural search and deep learning-based models to this knowledge discovery problem in an area that we know very well. It's basically the flood of AI research papers that's out there on arXiv and in conferences, and how to tame that. So we built out this platform basically first for AI researchers, and now we're mostly working with companies to use this technology to make Gen AI experiences possible on their own, on in-house confidential internal information. And in the last year or so, this has, of course, become kind of the de facto standard for building these type of prototypes. So we've seen and helped many companies prototype these kind of solutions, and I'm here to to share some of the war stories and our learnings and discuss uh, where Retrieval Augmented Generation is today, now in early 2024. And I'm curious to hear also where you think it's heading.
Yeah. Wonderful. Thank you for that introduction. It's a lot's changed over the last about 12, 16 months since December of 2022, or 23 rather, when no 2022 when ChatGPT was first launched, and generative AI has now come into storm. And you and I have been working with AI and machine learning for quite some time, both in research and in productionizing, building recommender systems. But this new interface, this new ChatGPT, really sort of took everyone by storm. And but RAG came shortly thereafter, right? What was the motivation for RAG? Why and what is? Let's just start. Let's just ground everybody in the audience. Let's make sure we all understand what RAG is. Retrieval Augmented Generation. I mean, I'll put a ticker up here. We can describe it there for those that aren't familiar with the term. But what is it, and why is everybody talking about it when we have this generative AI, this incredibly powerful AI? Why is there still RAG?
Yeah, so well, the basics is this. Like if you have a large language model, it's been trained on, on a huge amount of data from mostly collected from the internet, and you can basically engage it in a dialogue, right? You can use this chat interface, and you can ask it questions, and you can ask it follow-up questions, you can ask it to summarize information. But without RAG, all of that information is coming from some sort of representations that it has learned from the training data, right? It can answer questions like, "What's the capital of France?" and "What's the best way to make a Negroni?" But if you want to ask it questions about things that are current, like happening today, is not in the training data. And if you want to ask it questions about stuff that's only described in proprietary documentation or your own company internal documents, it was not trained on that, so it can never ever answer those kind of questions. So a lot of people want to ask those kind of questions and get accurate answers, and without RAG, basically large language models will make up stuff, right? They will do hallucination, as it's called, or confabulation. And RAG is a kind of software pattern which allows retrieval to supplement the information that's available to the large language model, inject it into the prompt, and thereby have a grounded and more accurate answer also on current or proprietary information.
Yeah, I love that description. It's a really wonderful description of why and the motivations for it. What was really interesting, my story around RAG was that when we were at Elsevier and we were building the first versions of Scopus AI, when they were still very much prototypes, for us in the academic space, in the academic publishing space, it was absolutely 100% critical that any information that we put on screen was grounded in the underlying literature. So this hallucinations or confabulations, as you talk about, I love that word. I love just saying confabulations. It's just a fun word to say. But that was a real showstopper for our customer base. We couldn't go to market with, if we asked a technical question about the makeup of causes for heart attack or various treatments for a high blood pressure, we couldn't just have that made up. It had to be grounded in the truth. And a product like Scopus always pointed back to the underlying literature. So we came up with a solution, and where we built a vector search, and we'll talk a little bit about vector search and why that's a key element to some RAG implementations. We built a vector search solution because we really wanted to build a natural language capability. It was really important, and we observed that when people were engaging with the content, they were using very short words to describe their intent. And we knew that for this type of content, you need to be more expressive. You need to ask better questions. And so we came up with the vector search, and we came up with a prompt solution. And then really a couple of months after we put our first prototypes together, I started seeing literature and discussion in social media about something called RAG. So we had effectively invented RAG internally on our own, and we had a nice label because everyone was calling it this pattern. So why is vector search and of course the vector databases that go along with it? Why has this become so popular recently? And everybody is now becoming a vector database.
Well, so I think we'll get to what the actual requirements are for the underlying search engine. But the reason that vector databases have become so popular, because in essence, if you have a really complicated question from the user, right, the sort of classical keyword search will not work really well, because you have a complicated question, but you're not looking for documents or passages in your corpus which contain a similar kind of question. You're looking for passages which actually contain the answer that complements that. And the answer might have very different lexical material. It might use completely different words, completely different syntax and sentence structure. And with keyword search in the past, that has been kind of hard to match questions and answers. And especially with these dense neural embeddings, you just train these large neural network models to basically move questions and answers that are semantically related closer together, and documents which are unrelated further away from each other in this vector space. And this creates a really easy to use semantic search, essentially.
Yeah, it's been exciting to see sort of the pace of innovation around semantic search. I think for years, having been around search engines, there are a lot of approximations. People approach semantic search with really sort of brute force approaches, like building lots of synonyms or even starting to deploy taxonomies, but they're always rigid and fragile, right? So you could build out a certain domain and you have pretty good representation of that content in that domain. But then if you asked a different question or came at it from a slightly different angle, it would be pretty fragile. And I think what we experienced with vector search was that you could really come at it from a broad number of semantic intents and really have it understand, or at least really map that semantic understanding very well.
Yeah, and
So
especially if you have longer questions which relate a lot of different concepts, and how how this compound interacts with that particular type of protein or material, and what the activity is. That's just kind of magic in terms of capturing it in these vector representations. But I would like to add, and I'm sure we'll have more discussion about that, vector search is not a silver bullet. There are many, essentially, the R in RAG stands for retrieval, and there's like a huge body of research on information retrieval going back decades, and not all of that has kind of been made irrelevant by neural search. And in particular, I think just want to point out that if you talk about question answering, RAG is like the new term for that, but there has been the same pattern. It was just called retriever reader for question answering, and that has been around for decades as well. So not all that is new is exactly innovative in that sense.
And no, it's true. I mean, I think these problems have been solved in lots of different ways. I think what's really interesting about sort of the AI and these new models is the ubiquity of them, the ability to sort of apply it to multiple use cases without having to build deep, specific solutions. So before we get into sort of the retrieval element, let's just talk a little bit about a typical sort of RAG architecture. What does that look like when you built it and you talk to your clients about it? What does that typically look like for you?
Well, typically you have a large language model which is the generative part, right? And in general, a lot of people use OpenAI, in particular, like GPT-3.5 and GPT-4. There are other vendors, and there are also open source alternatives. But in general, if you kind of start to experiment, yeah, why not start with sort of the highest quality one? And if it's kind of too expensive or too slow, you find an alternative. And you need some sort of retrieval, right? So typically people start by using some sort of vector database, but you might need something a little bit more sophisticated later on. And then you need some of the glue to put it together, which is basically like a templating engine, right? Like you're gonna have the user question, and then you're gonna somehow template in the search results, and then generate on the basis of that. And there are some really popular frameworks for that, like LangChain and Llama Index and a whole bunch of others. Um, are really easy to start experimenting with. There are like tons of blogs online which say you rag in 5 lines of code. So that's kind of how most people start. I don't know how you got started, Eric, in at Scopus AI. Did you guys use one of these frameworks, or did you brew something of your own?
Yeah, so when we built Scopus AI, it was just about a year ago from today. It's when we actually put the first version of it together. So LangChain was out there. Llama Index had just come along, and our internal learnings were that LangChain provided a great set of frameworks for connecting to various repositories. So it was great, and then implemented some really interesting mechanisms to flow through your data. But one of the things that we realized quickly is as we started to scale the solution up is that it was really tricky to troubleshoot. And so we ended up kind of just using it for core functionality, connecting to various different data sources inside the organization. But really sort of built that templating framework, that glue. We built our own. And I think that's
So did we,
what
by the way.
yeah.
And I think this is like a bit of a pattern, because any of the sort of the software vendors that I talk to, none of them use a LangChain internally. So it's a really an interesting community, and it's very vibrant, and it's a very good starting point for that journey. But in fact, not a lot of software products are built on it. I wonder why.
Yeah, no, I think one of the things I'd love to do is find the LangChain guys, or even Jerry from Llama Index, and bring him on and have a conversation about where he sees that resistance, because I think it's definitely a repeated pattern, that people are using it to get started, people are using it for experimentation, people are using it for proof of concepts, but it's very hard to take it all the way out to production. Maybe that's just the state of the state right now, and that could be another conversation: is why are we stuck in POCs and not getting all the way out to production use cases just yet? But yeah, that was our experience.
Yeah.
Um,
So what I've heard is that basically, since there's such a large community and there's so much experimentation going on, and there's also kind of this discovery process of what the abstractions and the framework should really be like, is changing all the time. And we worked with some of our customers who have used LangChain to integrate all of this, and there's sometimes like a pretty big push to rebuild and refactor to be up to date with the latest version, just because that's evolving so fast.
right, right. Yeah, it's a common pattern, and similarly, just the way we didn't end up using LangChain as our glue framework. We ended up writing custom code. Our core retrieval pattern was just Elasticsearch. So we upgraded to the latest version of Elasticsearch, which was another effort unto itself. But we used the basic approximate nearest neighbors vector search within Elasticsearch as
Yeah,
our vector database. So that kept our architecture somewhat simple in that we didn't have another moving part we had to think about. We didn't have to, and we did actually we took a look. And then this is sort of that learning path that we went through. Is we took a look at a number of vector databases, including Face and including Quadrant,
right,
including Weaviate, and we looked at them, and then we compared it to Elasticsearch, and the performance wasn't enough for us to say, yeah, it's worth jumping over. Um, so part of that evaluation of vector search is really identifying the embedding model, the vector space. how
right.
how do you think about that vector space, and how do you think about yeah, I know you and I both have our favorites that we use. But how do you think about, or how do you have that conversation when people come in and say, listen, I want to go and make an embedding and make a vector search. How do you approach that?
Yeah. So first of all, that space is moving really fast. So what was a good idea 6 months ago is no longer a good idea today. Um, and basically, there are lots of leaderboards like MTAP or Beer or Miracle that everybody's watching, and like every couple of weeks, something new drops and um, smashes the sort of leaderboard results altogether. And there's of course also commercial vendors, right? Like they're really easy to consume for especially large companies like OpenAI, really easy to consume through Microsoft. Cohere's out there, a couple other good vendors. Um, our experience is that um, the domain specific nature, like basically RAG has put relevance engineering back on the map, right? If you're going to template your top 5 results into the prompt for a very complicated kind of high expertise question, you better make sure that those top 5 results are really the right ones, right? So basically, in terms of traditional information retrieval metrics, you're mainly looking at like precision at 5, precision at 10, maybe MRR, right? And um, to get good results in terms of precision at 5 for a really complicated scientific domain or in-house kind of proprietary information with lots of specific terminology, the vanilla embedding models that are out there are not going to do the optimal job. So in our experience, getting a high quality open source model that you're able to fine tune then to really squeeze out the last sort of bits in terms of relevance and precision at 5 are the way to go forward. What did you guys use, and how did you kind of, what was your experience with this kind of relevance tuning in the vector space?
Yeah, no, so we ended up using Mini LM, the V2 and Mini LM, and it was great because there was a couple of dimensions that we were optimizing for. First and foremost, when we first got into creating embeddings, we were very concerned about a storage space and compute time that was required to create those embeddings, for not only for ingesting documents, because we have a large collection, we also wanted to manage our storage constraints, and then we were also worried about sort of any additional latency that would create, any different,
Mhm.
because we already used up our budget effectively for query response time. And so we ended up picking that model because it was small, had low dimensionality, but had been trained with a lot of content, and it didn't require, at least for starters, we could put together a really decent prototype without doing any fine training. In fact, it was interesting as we started to, because we believed that we could fine tune it and improve the quality. And we'll come back and talk about like why just the top 5 or why just the top 10. But we didn't have great success with fine tuning, and we ended up just using that model as it was out of the box. It didn't really move the needle at all for
Mm.
us when we started to fine tune it. But you're right. There's a lot of new models that are coming out right now, and even new approaches. Like I'm really excited to take a look at the new M3 models. Right, so they're creating three different representations with one pass. So
Yeah,
then
the
you have
VGE M3 models. Yeah, they're very interesting.
really interesting. So you now have that optionality to sort of understand the user context and then figure out which model to use
Mm.
at query time to engage with your content to depending on the use case. And so picking that up front, figuring out the right embedding model, figuring out the right even chunking strategy, and we should probably come back and hit chunking for a minute too. Those are things that you can decide if you know your use case very well. But if you're putting out a general public site where people may have different sort of questions and different problems they want to come at, it's very hard to just pick a path and say it's going to solve all problems.
Yeah, yeah. So okay, Mini LM was a very good model at the time and very computationally efficient, but it's indeed like the BGE models or the E5 models are very good open source models that are much larger and but give much better search relevance. Maybe because they're larger, they're also more kind of easy to fine tune. I mean, it's not child's play, but if you are able to fine tune these models to your own domain, we have this sort of approach of we call it impars. It's basically a way to take unsupervised data, generate synthetic queries for it, and then lots of those, and do hard negative mining. And with that approach, we were able to squeeze out another sort of 20% in terms of the precision at 10 numbers.
Yeah, that's fantastic. I think the areas that we saw the general purpose model fail us for the majority of these Scopus queries was really around queries that were very precise in their
Yeah,
lexicon. So things that were looking for very particular chemical names or project names, like things that just didn't really have any representation in the semantic space, weren't really talked about. What you wouldn't find in Wikipedia. Those are things that were failing pretty
yeah,
hard, and we thought we could improve that with the fine tuning. I think the approach that we ended up taking was doing more of a hybrid approach,
yeah,
where we instead of worrying about fine tuning the model, let's actually route those queries more intelligently, and do something like with RRF, reciprocal rank
yeah.
fusion, blend results back from multiple
Yeah, so
responses.
with fine tuning, you can kind of capture a lot of the semantics of the new domain, uh, but you're still dependent on the tokenization that's at the base of the pre-training of the base model that you come from. So if you're really looking to work on different languages than the model was pre-trained on, or looking for very exact matches on like part numbers or very specific chemical compounds, we had the same experience that basically you need to go hybrid. You need to make a blend of lexical search to have exact matches and semantic search with dense embeddings to get sort of the retrieval, the high recall retrieval, and kind of the synonyms, the related terms, and all that.
Right, which is now back to your point earlier. This is where we're falling back into the standard patterns of how do we do information retrieval, and how do we engineer those relevancy results.
Yeah.
Um, there's been a lot of interesting conversations lately about layering in knowledge graphs into the RAG applications. Have you tried to layer in knowledge graphs at all?
Not really. So I I sometimes find that people who are in knowledge graphs, they want to layer knowledge graphs into anything that they do, um, and especially if you have like smaller teams and not super well funded knowledge graph initiatives, it's just so hard to keep them keep them kind of to maintain those structures um, and if you kind of if you're not up to date and you don't have full coverage, your knowledge graph becomes kind of yeah questionable in terms of its usage. But I think if you have that resource and you have invested a lot of effort and money into bringing it to high quality, if of course RAG is not limited to unstructured data, right? You can template any sort of API calls, and I think you see that a lot evolving now in this sort of LangChain world into not just RAG but moving into agents and functions and tool use, and basically using any sort of external API to bring additional knowledge into the prompt. And I think that can be very powerful.
Yeah, that's exactly where I was going to go with that, right? And there's no reason why you couldn't layer in existing resources inside your enterprise or inside your application space and bring them in as part of that retrieval exercise. That data could be structured data that lives, in a traditional database or a NoSQL database. It could be another search engine. To drive up quality in our summaries, we found that in some areas the summaries weren't as great as we wanted to do. And so the approach that we came up with is this thing that we called RAG Fusion. And what RAG Fusion simply was the ability to take that query that came from the user that may or may not be great, but it was trying to capture intent. And then we take that query and then just do query expansion over to the large language model. So come
Right.
back, come up with some ideas, based on this query and potentially the results that come back as well. Come up with some other areas to explore, and then run those queries in parallel, right, against the vector search or against other data sources inside the organization, and then use something that very fast and very dirty, like reciprocal rank fusion, to surface the best results to the top that then we can then summarize into the generative AI. And that ended up driving up the quality and the depth of these summaries in a very nice way.
And how did you kind of evaluate it? How did you measure that? Because you're kind of what you're describing with React Fusion, you're kind of diversifying the different perspectives on what the query intent could be and how that goes into the database to retrieve the potential sort of needle in the haystack that's sitting around somewhere, right?
Yeah, that's exactly right. And so I think part of the luxury that we had at Scopus is we've got this really large data set, and so by exploring the content, we're exploring that topic from a couple different domains. So what are the political aspects of it? What are the social aspects of it? What are the economic aspects of it? We'd actually find literature that would support that from a vector search, and the way we evaluated it was simply we were in full disclosure, we were using GPT-3.5 to do for performance and speed and cost issues. We would then take those results, the question and the answer, and we ran that against like a larger model, a more sophisticated model, and we'd actually have the model come back and say, okay, rate this on cohesiveness, rate this on
Right.
completeness, rate this on does this make sense? And then of course, so those were sort of things we could do offline with the model evaluating the model. And then of course it was online evaluation from users. Do they like this? Does this feel like it answers their question? What part of this is engaging with those users directly to see that it and the majority of the time users will come back and say, wow, I hadn't thought about that angle before. Which is the experience we have when we sit down with ChatGPT and you say, help me come up with whatever, right? Help me come up with a plan to pick this argument apart, or help me make a presentation. Like, oh, that's a really good point. I hadn't thought about it, taking it from that angle.
Yeah. Yeah, I mean, there are. I want to come back to evaluation in a bit, but I think the RAG fusion is really interesting because sort of the basic RAG pattern just takes these five, top documents or top passages and chunks them and templates them into the prompt, and that's really limited, right? Because there are many different types of questions where you want to know what is everything about X? Are there any approach? Has anybody tried anything to solve this problem? And you're not just happy with the top five answers, you want to know all of them. And so I'm really excited about rank fusion and sort of these massive parallel approaches to retrieval because it has the potential to actually like completely and satisfactorily give you all the answers, including like is this still up to date and all that.
Or even at least come up with a sort of nice topic page, which is a sort of an information rich and information complete representation of your answer. And yeah, you're right. And that's exactly what we found. And running these queries in parallel actually didn't impact our budget that much because the majority of the time was still spent
Because the
waiting for
search
the
cluster is
LLM.
there anyway, right? Yeah.
Exactly. So that's where we were coming from. So
And I think it's really interesting that basically this RAG approach and large language models have completely changed the way we see search. Right, the new era of search, the actual retrieval is the foundation. But in terms of computational budget, is just a fraction, right? Like before GPT-4 generates this whole summary, it takes so much time that you can run back and forth to the index like dozens of times.
right, you can go back and just keep asking questions or say, oh, do I have enough here to feed it? And before we were, typical retrieval systems, we were trying to maintain under 300 milliseconds, under 500 milliseconds, maybe for a retrieval pattern. Now that we're waiting for this generative summary to come back, I think we're all very happy, or our users are very happy to see, okay, something's working, it's thinking about it, it's starting to give you some answers back, and I have some time to think about it, which is a different paradigm. As we step into other use cases, not just information and question answering and summarization and topic generation, as we step into some other domains, which we'll see this technology apply to in the future, even 5 minutes or 10 minutes is still, and like if you think about the legal domain, or you think about patent research, for example, those are perfectly reasonable amounts of time, because it would take a human hours, if not days, to do that research and come up with those summaries. And so we're starting to see that shift now, where it's really acceptable to have a longer period of time for our first response.
Yeah. And so I want to say one more thing about evaluation, and that's really like, as we get these more sophisticated answers to question and these kind of summary style digests of whole topic domains, evaluation has just become so different, so difficult in some sense. And I think you alluded to that. That is also kind of completely shifted from manual human evaluation, because it's just too time consuming to evaluate 500 summary kind of answers. But large language models can do it really well. And so basically you don't no longer have a gold standard, but you can ask this very powerful model to evaluate your output on a number of dimensions, but also to compare different versions of the system to each other. So just want to make a small plug to something from our evaluation practice that we have open sourced, which is a toolkit called RAG-ELO. So RAG-ELO style evaluation, where we can compare different versions of your prompts or your system or your embeddings or what you like, and do a kind of chess style ELO tournament. And then you don't have a gold standard, but you basically end up with a good ranking of what is your best system and what's your second best system, etc. And whether something you have changed is actually an improvement over something you've done before.
I'm so happy to hear you talk about that, because I think that was, as we're going back to the earlier part of our conversation where we're talking about frameworks and evaluation and quality was definitely, it was and still continues to be a large gap in that framework. How do you know the embedding model is making a difference? How do you know that your chunking strategy is making a difference? How do you know the prompt changes and so how do we actually put some some quantitative evaluation around this, that I could actually A/B test, right? That I could actually validate. And it's great to hear that you have a framework. We should definitely socialize that. I know they're starting to see a few others. They're starting to emerge, and so we'll have to keep an eye on those and see which ones mature, and how we're going to tie those into our existing frameworks. Because we've created this wonderful experience with RAG, but they're as you said, the retrieval part, which used to be sort of that was it. Then we just evaluated the documents that came back. Now it's just one of the pieces that has to go into this orchestration, and we have to think about how that whole flow goes together.
Yeah, there's this whole orchestration ecosystem evolving. And there's some really cool new stuff. One that I really want to shout out is DSPy, which is kind of a different approach than LangChain and Llama Index, which talks about this whole orchestration setup as a kind of compiler, where you have different modules which you compile together into an LLM program, and that's a really interesting approach pioneered by people at Stanford.
Yeah, that program looks really interesting. I did see that and some of the initial talks on it. Being able to treat these whole stacks, these whole slices, as a version or version software even that I could I can think about and then evaluate as even as a binary or as a compiled version is I think it's going to be critical as we think about scaling these solutions. Really excited about DSPY, and also really excited about some of the advances that we're seeing with technology. There's a question here that came in about Colbert, and what it's doing with sort of its late binding. Have you spent any time looking at Colbert at all?
Yeah, I think Colbert is showing really good benchmark performance across sort of all the academic out of domain generalization benchmarks like beer and related. I've always been a little bit skeptical of Colbert on like really large collections. I don't know if you guys had similar thoughts when you were working on Scopus AI with this sort of millions and millions of documents. Basically, there are a lot of optimizations in the newer versions of Colbert, but I'm still somewhat skeptical of it being able to scale to like 100 million documents with high retrieval quality.
Yeah, I don't have the facts on that yet. So I think we have to continue to take a look at how it's going to scale. The benchmarks look promising, but given that it shifts everything towards the end, does that late binding, that late interaction pattern,
Yeah.
how much has to be actually put into memory to do that combination? And unfortunately, I don't have the numbers on that just yet. But I'm really interested to see where that goes.
Well, maybe you should invite Omar Khattab to one of your next conversations.
That's a great idea. I think I would love to have a conversation with Omar, and understand what he's doing. He's done some great posts and gathered some great benchmarks. But it'd be great to see how we apply this into some of our production systems.
Well, but kind of to maybe short circuit that discussion a little bit. So if you're talking about RAG, you're really talking about the quality of um, the relevance mainly of the retrieval and the quality of the subsequent question answering or summary generation on top of that. And to some extent, your users couldn't care less which kind of database you're using, which kind of you know um, embeddings you're using, as long as it works. So I think sort of I would always almost recommend start with evaluation. You can even do RAG with keywords. You just might encounter some like cases which you cannot solve, and then you need to improve from there. But set your baseline and iterate from there. Don't go for the tech that you're in love with.
Yeah, no, exactly. Always fall in love with the customer problem, not your solution, right? Yeah, you can build RAG. You can build a RAG proof of concept by just calling Google search or Bing search, right, and bringing some results in off the web and getting it just to play with templates and to play with prompts to drive that a bit. Super. All right, great.
So, Eric, we've been talking a lot about sort of what our experience and some recommendations, and what we've learned the hard way. I'm curious to hear from you. What are some of the sort of more recent topics in RAG that you're really excited about? Where do you think people should pay attention? Where it's going?
Yeah, so the things that I'm really interested in keeping a close eye on with RAG is, and I think you mentioned this a little bit earlier in our conversation, is the concept of agents or tools and how we can assemble those tools. The way I see RAG going forward as a solution longer term is that instead of it being sort of just a one dip into a single repository, or even asking multiple questions into a single repository, as we talked about with RAG Fusion, I see that the LLM layer becomes this really interesting orchestration layer, right? Where it can now come up with a strategy, right? It can come up with a workflow, and it will be able to assemble pieces or agents or tools that it knows about inside your environment, and be able to dip into the various repositories or the various bits of information that it needs to assemble those to solve those problems. And this is sort of a really feels like a really reusable pattern that's going to come out of it, where you can have multiple. It could be multiple LLMs involved. It could be multiple agents, multiple tools. But those agents can then be responsible for connecting deeply with your enterprise resources. They could be responsible for deeply understanding security mechanisms and ACLs and things that are critical to the enterprise. And then that LLM really then becomes this, this workflow, or this, sort of lightweight project manager that kind of calls those agents, gets them to work either in parallel or in sequence to then start asking questions about your enterprise. And so this will enable all sorts of use cases, like people that want to engage with the analytics data within the enterprise and say, well, what is our Q3 forecast? Right. And it's simple, very simple question, but to answer that, right, you have to dive into all these different places. You have to pull it up and say, well, okay, the Q3 forecast is down. Why is it down in Eastern Europe? Right. Boom. So let's go into the other repository and find out. So starting to get that engagement with the deep analytics, and then what products are we selling right into that space, or what products are we not selling into that space? Help me understand why. As an example, so that's where I think things are going to go with this architecture. We just saw some recent press from OpenAI about a couple of agents flows that they're working and building. And so I don't think I'm alone in saying that there's going to be some interesting topics that come out of an agent. I think there's going to be an agent that, if I remember correctly from OpenAI, they're talking about something that's going to live inside your phone as an agent. And then another one that's going to start to take together some of these sort of more complicated. I mean, Jakub, how many times, like we talk about these workflows, right? Just you and I just trying to schedule an email call or get a call going with our team, or buy a ticket to travel somewhere, and how much friction there is involved in that process today. I think we're going to start seeing these workflows where we have automation and interaction with real humans that have to do things and give feedback become more and more encompassing. That's what I see coming over the next probably quickly.
100% agree with that, and I think it's less remote into the future than you might think, because actually, if you build a really simple RAG system and you make it conversational, you basically allow subsequent interactions with the user. Immediately, you get to the agent pattern, because at every future utterance of the user, you're going to need to decide whether you call out another search because the topic has shifted, or you refer back to the memory of the earlier conversation. That's already a simple agent, and you can build it to endless complexity from there with other tools and other capabilities, and multiple different agents interacting with multiple goals and all of that. I 100% agree. That's a very interesting direction. And don't forget memory, right? Like, I think it's fair that the user expects that the agent remembers what you talked about last week, or what what your preferences are, or who you are, what you're trying to accomplish.
So there's been some recent advancements in context length, right? We talk about memory, right? Context, or the length of context, is really how we model that today. And there's a little bit of I think there's still some issues right now where the language models pay very close attention to the beginning of the context window and the end of the context window, but sort of that man in the middle, that sort of lost in the middle bit happens. Are we going to get to a point where these context windows end up acting like RAM inside your computer, where I basically take my entire enterprise corpus and load it up into a context window, and the LLM says, "Oh, okay, great, I've got this big context window up here, and I can access any bits of it by navigating, some parts of the vector space, or looking at clustering of information that's relevant to the conversation." How do you think that's going to evolve from a model development perspective?
Yeah, so context length in tokens is really precious, right? In LLMs, and you just want to kind of fill it in a very economic way, and RAG is certainly pushing the boundaries of that. And we've basically seen over the last half year, moving from like a few thousand tokens to 100,000 of tokens, or there are some more recent sort of R&D-ish models which take that to infinity theoretically. But I don't really believe that's like a fundamental new property of the system. So it's nice to have a really large context window and to be able to fit in lots of different stuff. But if you look at sort of, let's say in your example, all of Scopus, right? That's not going to fit into any sort of reasonable RAM memory at any point in the future. And it's going to need to be updated all the time with new content and retiring old content. So I don't really believe in this sort of infinite context window as a replacement for the actual retrieval engine behind the scenes. It's like a human memory. You have like this short-term memory, which is full of stuff, and with smart people it's kind of large, but still you need this long-term memory, and sometimes you need to think a little bit to retrieve the right parts.
Yeah, no, I think so. So long live RAG, right? RAG is here. It came as a in short, it came as a solution to deal with hallucinations and confabulations and loading short-term memory, loading current events into the system. Long term, I mean, you're right. I mean, if you think about just creating the citation model of all the relationships of objects and nodes, that loading that into memory was dozens of gigabytes that had no content in it, right? So you talk about loading all 90 million articles. We don't have systems that can hold that right now. And then, right, there'll be a diminishing returns, right? Why should I bother putting that system with all that memory in there? It's just quicker to go pull it from disk, right? It's more efficient because no one's really engaging with it. So it's here. All right. Well, this has been let's see. Are there any questions that we want to take on here in the Q&A? There's a question about will RAG evolve to adapt with vision language action models? What do you think about that one?
Absolutely, yeah. So we're actually looking at that right now. So when you look at sort of proprietary information inside high-tech companies, a lot of it is like manuals and maintenance procedures, and you have machines with lots of diagrams, like the little LED on the right corner of the lever here. When that starts blinking, then go to step number 5 in this flow chart. So you will absolutely need to embed those drawings or diagrams. And I think in scientific papers it's a little bit less urgent, but in sort of in engineering it's super important to have drawings and kind of 2D and 3D representations. And I believe that I'm not so sure how good GPT-4 is. I think it's kind of rumored to be very good in multimodal, but there are no real sort of information on what it was trained or on anything. And Gemini is also rumored to be kind of multimodal from the ground up. There's people like Reka and a couple others who are developing, like small startups developing multimodal models. I think is definitely sort of the year where that becomes mainstream.
Yeah, no, I think that's a great point. I think I think also, not in addition to engineering documents, so these highly detailed specifications and and design documents, I think another interesting place that we can see multimodality. I'm working with a friend of mine who's trying to put together an e-commerce app, a shopping app, right? And so it's one of those things where you can imagine finding a style or a clothes on social media, and then saying, well, how do I actually shop that style? Which actually ends up being it's a huge use case driving e-commerce, and it starts with an image. It starts with a picture that then has to drive into an e-commerce catalog to actually find it and then find the best price, right? So it's a really interesting opportunity to drive multimodality. And then what if you're taking it from like a red carpet shot, right? So it's someone's in motion or it's blurred, right? So you don't have a crisp sort of image of it. So there's a lot of interesting use cases that can come out of this. All right, cool, good. All right, we're getting to the top of the hour. Any final closing thoughts that you wanted to capture? There's one more question here about RAG paired with specific Q&A models. I don't know if you want to take this one on or not.
So yeah, I think there were a lot of Q&A. So the question is like, um, does RAG have a coexistence with specific state-of-the-art question answering models that have been, specifically trained on question answering? And um, I think like the level of language understanding of these generalist large language models that have been trained on trillions of tokens for, you know, uh, um, um, many petaflops of compute, and they're just so good that is very hard to compete with that, and they generalize really well. And yeah, I think so. I've been in NLP for like 30 years now, almost, which is embarrassingly long. But basically, this sort of LLM capabilities to understand and generate language, that's what we were hoping for, is here now. And I think NLP has profoundly changed, and building task specific models on small manually annotated data sets is kind of over. It
Yeah.
might still be like today, there might still be a reason to do it on this particular domain or task, but it's going away.
Right. We have a whole new set of tools on our tool belt that we can use to address these problems, particularly in language domains and then cross-lingual domains. I ran into a startup that simply wanted just a really good translation, and they were fine to say, like, give me, it can be 80% accurate. I just need someone that's on the ground in this country to be able to talk to someone on the ground in that country, just to be able to just get a conversation going. And so just simply like language translation as a use case to enable NGO activity, to enable humanitarian aid, to enable is a use case that now we can start thinking about. So
I like this one last question from Dennis de Vries. How do you handle vague questions? Can you generate smart counter questions to extract extra information from the user to make the conversation uh, bidirectional?
yeah, yeah. So yeah, this one. I mean, the first thing that jumps into my head is going back to this. This was sort of the approach that we took with Rag Fusion, was just going off and sort of spraying out and coming up and looking at a question, understanding that it's vague or understanding that's very high level, and coming out and asking, the vector search, multiple different questions from a couple different angles at it. So that was one approach. Going back to that Rag Fusion idea, the other one too is that this is also an opportunity, as part of the templating you can do as part of that generation. This is also an opportunity to start to use the language models to train users again. So we can come back and say, okay, thank you for asking your question. Have you thought about asking the question this way? Or have you thought about exploring this way? And so part of that user experience that you can now develop using RAG, part of that generation can be, here's other places that you can explore. Here's other ways to dive deeper. Here's other elements that you may not have thought about. So instead of just doing it automatically on behalf of the user, kind of present those as choices so that they can say, oh, wow, I didn't think about asking that kind of question, and train them to get better at asking questions. Super good. All right. Well, Jakub, that brings us to the top of the hour. I can't believe it went an hour on by so quickly. Thank you for spending some time with me on LinkedIn Live and having a conversation. All these questions will be up online. They'll be tied to the LinkedIn Live. The recording will be up there soon. And then those recordings will come back, and any questions that we didn't get a chance to answer, we will come back and we can address online as well. So.
It's been a real pleasure, Eric, and I just wanted to say we did not use RAG during this conversation. It was a purely 100% human mixed initiative dialogue. And
That's right.
we hope to keep those in our future as well.
That's such a wonderful closing point. I love seeing when people make a post on LinkedIn. This is entirely human generated. No AI was involved in creating this post. And you're right. All through our strengths and our weaknesses, this is all human generated. So thank you, everyone. Thanks for joining. Thanks for all your questions, and we hope to talk to you soon.